Hi guys, welcome to Learn Electronics Repair, and I have this on my bench today. So this is actually a PCB, as you can see, from this Opera 510DX. This is a DigiPro G2. So this is active speaker basically. It has two Class D amplifiers on here. We can see the two controllers here, pairs of MOSFETs. One of these drives the tweeter, one of them drives the woofer. We have schematics for this, and initially I spent quite some time trying to repair this speaker. So these are kind of renowned for being difficult to repair, okay? And on my first attempt I couldn't really find a problem with it. I published the video. There were quite a number of suggestions from you guys out there, so I made another video where we went through the various suggestions, some of which I was convinced wouldn't work, and I explained why, some of them which were possible, and it turned out that at least one of you, I think there's more than one, figured out the problem is that these inductor coils, so we have one here, and this is the remains of the other one here. One of the coils had failed shorted turns, okay? And what that causes to happen is the Class D amplifier on that channel continually tries to boot and then reset and boot and reset, and you get a click, 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 click on the speaker, okay? So that's what was wrong with this one. Now, I couldn't find any of these particular coils. And there isn't much space in this thing either to fit something else, okay? So these are the actual coils. There is some marking on this, I'm sure. Can't really read it now. Try this one. Yeah, this one's a bit better. Okay, so there is a marking on it, you can see, but I couldn't actually find the correct ones. The value of them is about 23, I think it was millihenry, you know, could have been microhenry some time ago. I think it was millihenry. So the only real option left was to rewind the coil, and that's if I could get the thing apart. You can see these are like sort of sealed, potted. So the story goes along. I, on the next live stream, said let's see if we can do this, and most people said heat it up. Yeah, so we got it very hot, and this is the winding out of it. So there's like black gunsy stuff in here. That's what was holding it all together. Like I say, potted, okay. This was the end. Just close it down a little bit. Sorry about the focus, guys. Yeah, one end kind of sticks out through the bottom, and then the other end kind of like you can see bends over there and goes out. And I think it was on the outside of the coil, but it could have been on the inside. Okay, I think it was on the outside. This then got put on one side because the senorita who owns these speakers was going to one of the neighbouring islands of Lanzarote over the spring and summer. She didn't need the speaker at the time, so it kind of got put on one side and then kind of got forgotten about, really, as happens, yeah. So in the meantime, two things happened. Firstly, Detlef found this at the car boot sale at the flea market. So this is off a similar speaker, DigiPro. I'm not sure what he paid for this, maybe 20 or 30 euros. He might
20
even.
bucks.
So how much?
20 bucks.
20 bucks, okay, paid 20 euros for this. And they said it was working, and of course, what happened? You plug it in, it goes click, 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 click. So at this point, I said, look, I know what's wrong with that anyway. I think the trader wasn't even there the next week, so this stayed here. And this is the other one. So this is not exactly the same, but it's very similar. And I can see, and you can see down there, the inductor coils. Yeah, the two of them. So that's one thing that happened. We have another one. And the second is this weekend, she actually contacted me and said, hey, if you've still got my speaker, it's been too long. So I thought, okay, well, let's see if we can finish this repair, and let's have a look at the one of Detlef's as well. And if we do, and it's the same fault, then we will get the winding out of that one on video. Save me finding the live stream where we did it. Okay, so that's the preamble. Now, if you look at the former here, there's still gunge in that, yeah? So probably I'm only going to get the coil back into it by getting this hot again, I think. You may be able to get it hot and get that stuff out of it, but at this point I think you may as well get it hot and stick the coil into it. Yeah, at least that'll hold it in. So that's the first thing. We have the wire. So this is 1mm. We measured the original wire from this one, and as far as we could tell, this was 1mm. Let's have a quick look. In fact, let's look under the microscope. I think they are the same or close enough. We will see, yeah. So we can definitely see now there's quite a bit of the sticky stuff still in there. Okay. And we can also see that these look to be the same diameter to me. Yeah, we measured it with a wire gauge actually, that one, so should be right. Okay. So the challenge is to get this enameled wire, by the way. This is coated with like a kind of, well, it's enamel, but imagine like a lacquer, so it doesn't short when you wind it in coils. Yeah, it doesn't short to itself. So we need to get this enamel wire wrapped around that and back into that. That's the challenge. Now I will say I've never done this before. Yeah, so me throwing caution to the wind, I'm just going to do this on camera. Yeah, and we'll see how it turns out. Either it will be successful or it will all go, to coin a technical phrase, tits up. Yeah, and then I'll be asking you guys, but let's see. So I looked for some videos on winding coils, and I honestly have never wound one. They seem to fall into two categories. One was winding toroidal inductors, which is a different technique. And the other one was to use a winding machine to wind these, but bigger. So this one, it has, I think it's 13 turns, and we can see because it's very rigid when it came out. So we have 1, 2, 3, 4, 5, 6 to here, 7, 8, 9, 10, 11, 12 or 13 turns. That's what we have. Okay, we do have the other one. So in actual fact, we can measure the value of this before we start. Let's just see what it was. I'm pretty sure it was 22 something or other. Let's see. Okay, so I have the LCR meter. I have it set to inductance. Okay, let's have a look to see what we have. So this is the good one. Yeah, 24 microhenries. So it was microhenries. I remembered the value, just like not the decimal point. Yeah, which is probably quite important. But anyway, yeah, 24 microhenries is the good one. The bad one read about 2, by the way, before we dismantled it. So I'll just try and get the last of the gunge off this. Yeah, it looks pretty good though, to be honest. Don't see any particular amount on there. It all depends on how much clearance there is between here and here. If we look, there's a reasonable amount of clearance actually. It's not like really tight. That is quite possibly in our favour. Let's get a piece of the wire. Yeah, we seem to have a reasonable amount of space in here. Just trying to, yeah, look, that's not so bad. Okay, so it looks like I should start from this end, bend this 90 degrees, wrap it all the way round, and then come back down the outside and through that one, yeah? Okay. I'm trying to like feed the wire in straight. I'm not kind of like looping around like that because that effectively twists the wire. But I say I've never done this before. So that's the first 1, 2, 3. This is 4. I'm having to do this quite tight because obviously I need to make sure it fits onto the former. And this is quite stiff. This is quite hard on your fingers, I will say. Okay. Not easy. Another problem I'm finding is to keep this bit straight and going into that notch without leaving too much of a gap, if you see what I mean. Yeah, that's the problem I'm finding, because I don't think that will work. I think this needs to effectively go in here flush. Probably lose some fingernails here. Okay, keep going. Okay, the problem I'm having here is I'm running out of former. Yeah, you see I've got, starting from here, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. I need at least one more turn. I think I'm going to wrap, yeah, put the former over this end and put another turn or two on there. It looks like this is actually deeper than that, if you see what I mean. There's a bit of space, so it's quite possible the original coil wasn't all around the inner former. Yeah, so let's keep going like this. Okay. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. I have 12. Right. And then I'm going to bend this back down. Obviously we need to put the former another way then, and then bring it out from the bottom. So it's actually even pushed in. It's just, well, it just about fits actually. Okay, so we bring this wire down here, okay? Something like that. Take this off here, and I'm making this up as I go along, guys. But you know, I couldn't find any specific instructions for doing this. Yeah, something like that. Let's cut this off and see if it fits inside the housing. Yeah. The good news is I've got plenty of wire. Will this fit? Actually, yes, easier than I expected. I thought that was going to be, it's calling another technical term, a bitch. But in fact, it's gone quite easily. I noticed this one is a bit more recessed than this one. It was like that originally in actual fact. I don't want to push too hard down on this because I don't want to crack that. That's the worst thing, really. Okay, so, yeah, it's gone in. Okay, let's measure this and see whether it reads anything like the value we want. I'm tinning this by putting the soldering iron on boost up to about 450. I've scraped away at the enamel a little bit, but yeah, that kind of like breaks it down. Okay, so conductance zeroed. What do we have? Well, we have about 10.5. Okay. Hmm. 23. That's not looking good. So there's the coil. I mean, it's wound up. It's wound in as much as I can get it. 1, 2, 3, 4, 5, 6. Yeah, 12 turns, okay? But reads nothing like you would expect. Yeah, about half. Let's have a look at the ones on the other amplifier. I'm going to unsolder them. Let's measure them as well. I don't see that the problem is the amount of turns. Yeah, we can see basically on the other one the amount of turns we had is there. Even if I'm like one turn out, I mean, come on, you know, half the value. The other possibility, what's happening here, is that we had to get this very hot to actually get the winding out of it. And it may be that, as somebody mentioned on that live stream, we could have effectively degraded or damaged the ferrite. That's the former this is wrapped around. So in other words, it loses its magnetic properties or something like that. Let's take the top off this. I'm interested to see how much difference that actually makes to the reading. Okay, well, yeah, it now reads like 4.2. So obviously this has quite an effect. Does the direction of it have an effect? Told you I was making this up, but told you I was making this up as I went along. Yeah, investigating. So that goes 10 point something. Let's go the other way. We'll turn this around 180 degrees. We're going that way. I'm pretty confident like the little notch there lines up with the notch in here. We can look at the other one in a minute. So let's turn it round. What do we have now? Not much difference. A little bit higher, funnily enough. Here's the other one. Yeah, we can say the little notch there lines up with one of these. And is there a dot there? No, it's maybe something stuck out. There is a notch though at one end, specifically. Okay, so with the notch at that end we get 11.3. And we'll take it off. We get 4.8. We turn this 180 degrees. Okay. 10.1. You don't suppose the direction of the winding has any effect on that? Bit of research. Well, no, the direction of the winding doesn't affect the inductance. Okay, it does determine the polarity of the winding, but this is then important with transformers. This is just an inductor. So in this case, I can't see that actually does matter. So I do think that is the cause of the issue. Which brings us back to some problem with the properties of the ferrite former due to us getting it very hot, which we had to do to dismantle it. Okay, let's get the ones off the other amplifier and see, first of all, does it have the same problem as this one? This is the PCB off det speaker. You can see there's a great deal of similarity between these. The heat sinking is quite different between the two. But other than that, there's a lot of similarity actually between the DigiPro and the DigiPro G2. Okay. We know what was wrong with this one, but the coils actually looked okay on it, just one didn't read good. But this one, wow. That's what's wrong with this one. So I think we can confidently say this has the same fault as that one. Let's unsolder the inductors from this one and measure these. I'll do the damaged one first, which is not easy because they're actually glued down. Can you see that? A lot of glue on there. I can say for pretty certain these are the two pins. There's something else there actually. Oh, what's that? Is that a pin? Yeah, maybe. Okay, so looks like this PCB was kind of designed for two different possible size, physical size inductors. Okay. Yeah, coming. Even with the glue, it's still going to give it up. Okay. Definitely, yeah. One end's free, you can see that. Oh, the other end might actually go there, you know. Let's try. No. Well, it looks like it goes here. Nope. Let's see if we can see that slot. So there's a slot in the board here and here. It's definitely the other side of the slot, okay. It either goes, look, I think it actually goes under the plastic of this connector. Yeah, these here, look, you see there's a resistor and a resistor, so that appears to be that. This is going to be fun. I'll try and heat it up down there. Let's see what happens. But seriously, guys, it looks like it actually goes under here. Thank you, whoever built this thing. Let's try this. Okay, it's off, just the glue holding it. Well, I can actually see now, that's where that was soldered. So it was the inside of the slot, it wasn't over there. Okay, so it's there and there. Right, that should help getting this one off. Okay, so this one marked 998 AMF. That's the one I've just taken from the DigiPro, not the G2. Okay, I just put a green mark on it so I know which one it actually is, because you know it's so easy to mix this stuff up. So it says 998 AMF. This is the good one from the G2. Can't read. This is the one I rewound, but it's not good now, so it's the same. Okay, and then this is the one that's kind of like blown its top. So this appears to be a common failing with this. This one, it looks like it's got so hot it's actually shattered the former. Yeah, that's what's happened. It's just blown the end off it. You know, I can't say I've ever seen that before. You'd expect that from a capacitor, not an inductor. Guys, down there, yeah. So, what did he read? There's clearly no chance of rewinding this one, by the way. So this speaker is at the moment scrap, and it may end up donating this for the other one, to be honest, and I'll end up donating Detlef 20 bucks, as he called it. So that reads good, 22.3. Okay, so we have two good ones. And this one, something came off, try again. 6. Okay, so we're learning things. Firstly, the former is important. Yeah, the former is important. So my best guess on this one, there's nothing wrong with my rewinding, but the former itself has somehow lost its magnetic properties. Yeah. But heating apparently can damage a ferrite core, causing irreversible changes to its microstructure and magnetic properties. Overheating beyond their designated operating range cause effects such as loss of inductance. So that looks to be more likely what has happened to our ferrite core. You know where to talk about that, yeah? So what I have two good ones. And I'm going to put them into the speaker that belongs to a customer because it's a paying job. And I'll add on enough. So this one now, well, we couldn't have fixed this anyway because of that. Yeah, so this one now needs 2 inductors. And to be quite honest, it looks like if we can find these, then we can probably fix most of these DigiPro and DigiPro 2 active speakers. And there's lots of them because this kind of speaker is like a sort of an OEM amplifier that's used in quite a lot of different brands. So that has got to be worthwhile. How do we either A, get good formers, or B, get the inductors? Now let's put these both into the other speaker. Okay, I've soldered those to this board. The legs are very short actually. I had to get a bit of wire effectively into this one to get the solder to bridge properly. But we can see we have a good connection. Good connection. Okay, so let's try this and see if it works now. So I'll just put the current limiter on. It's over there. Set it to limit. Just check this first. So right then it goes off basically. That's good. So switch on. Let's see if this actually does anything on the indicators here. Well, they all go out. It doesn't click anymore. Okay. Bad connection on the... Oh. Then it starts to buzz. Maybe a problem with my wiring that. Let's just check again. Use the other one. Okay. Doesn't do anything. Music. Oh, they starts buzzing. Okay, so what we have now is a completely different fault. No longer clicking, but you can hear. So after a few seconds, bass speaker starts buzzing. I just want to make sure that switch is in the right position there. Actually, let's just go again. On. Okay, so it has a completely different fault than before. And that, guys, is another video. We have a schematic for it, so we need now to figure out why we have a continuous buzzing noise on the woofer. The tweeter is working. No longer clicking, so we fix that problem. We have another one. Hey! Seems the life of a YouTube repairman just isn't as easy as you might hope. Talk about it down there. And hopefully I'll see you all soon again on Learning Electronics Repair. Ciao for now, guys.